Hello, this is going to start our unit on states of matter. So we're going to start with gases. And for gases, we have to talk a little bit about kinetic theory. So kinetic is motion, so this is going to be about the theory of the motion of gas particles. And kinetic theory states that particles in all forms are going to be in constant random motion, so they have no predetermined path. The energy that an object has because of its motion is kinetic energy. So for gases specifically, gases are composed of small particles separated by empty space. They are in constant random motion, and all collisions are perfectly elastic, meaning that kinetic energy is going to be transferred without loss. So the energy that one particle has when it runs into a second particle is going to be transferred. The kinetic energy is going to remain the same. Gases are going to have a really low density due to that large amount of space between the particles. They can be compressed, which would increase the density. Allow them to expand would then decrease the density. For gas pressure, that's going to be the force exerted by a gas per surface area of an object. So for example, when you fill a tire up with air, it's in pounds per square inch. So the force would be pounds per square inch would be the surface area for the object. If you have no gas particles, you can have no collisions, and therefore you would have no gas pressure. This is called a vacuum. So the pressure that is exerted on Earth is the atmospheric pressure, and that results from collisions of air molecules with objects. So the Earth, water surface, buildings that we've built, mountains that are here. Atmospheric pressure is going to decrease as the elevation increases. So as you're moving up a mountain, there is less atmosphere pushing down on you. It is going to be dependent on the weather. So on a sunny day, you would have a high pressure, and on a cloudy day, you would have low pressure. SI unit for atmospheric pressure, or pressure in general, is the Pascal. We don't use that one as often. Other units are the torr, the atmosphere, which we use frequently, millimeters of mercury we use often, inches of mercury is used by meteorologists. We tend to use a kilopascal. And to measure pressure, you're going to use a tool called a barometer. So 1 atmosphere is going to be enough pressure to support 760 millimeters of mercury in a barometer. So barometer, if you were standing at sea level, it's going to go to 760 millimeters of mercury up here. So the atmosphere is going to push down on this container of mercury. Mercury needs somewhere to go, so it's going to be forced up this column, which is actually a vacuum, so there's no other particles in here, so the mercury is free to move up the column. If you were on Mount Everest, you would expect that column to be lower, because the higher you are, the less pressure there is, so therefore the column of mercury is not going to go as high up the column.